So we are often to write in our plate theory derivative of w with respect to x, those are the slope, derivative of w with respect to y, second order derivative in the moment expressions. It is required to write this kind of expression. So we try to follow the grid, and according to the definition of partial differentiation we can write del w by del x. Now you imagine that one part of that grid in the x direction, one of the grid. Now 0, wherever when I have written 0, it is the where the w0 gives you at the coordinate x and y. w0 is a value of deflection at this point and is a function of x and y. Now one take for on the right hand side I have denoted 1, left hand side I have denoted 3. This is x direction. You can mention w1, w0, w3 like this, and you can also write the coordinates x plus h, because you are increasing this by x value by h, decreasing x value by h. Y remains constant because this is x direction, because I want to write del w by del x. So simple differentiation, partial differentiation definition will give you w written at here and minus w written at here. Central difference. So what is the value of w here? It is w1, and value of w here is w3. So slowly we progress up to fourth order. So slowly we start writing these kind of equations. Now I'm coming to del w by del y. Again we write, we take y direction, and according to the grid which I have shown previously, I have redrawn here where y direction the ordinate values, the numbering can be random. You can define your own number provided the values you are writing should be matching with our difference equations of the function value at that particular point. So in y direction you can see the function value varies with respect to y in upward direction and decreasing with respect to y, I mean the coordinate value decreasing with respect to y. X remain constant. Again we write according to our partial differentiation definition. We simply write, this is w0, w2, w4. You can check here w2, w0, w4. So we mention w2 minus w4 divided by 1 by 2h. Now we go further. Del square w by del x square. So we use a formula which we had earlier defined. Yn plus 1 minus yn plus yn minus 1. So we are going to use this formula if yn is w0 here, and here this is, we are going to write in x direction. w0 is here, w1 is here, so this is w1, this is w3, and this is wn, yn, w0. So very easy to write this second order also using this formula. Now we can write the second order differentiation with respect to y square, del square w by del y square. Now you have to look at this direction, vertical direction. Mention your function value, that is y in y direction. You can use the same formula, but what is the next value and the lower value? Yn plus 1 is 2, so w2, yn is 0, w0, and yn minus 1 is w4 in y direction. Similarly, now we also have to write the differentiation with respect to x and then with respect to y. So first we take with respect to delta y w and then delta x, the difference equations. So delta y w you can easily write this way. It is delta y w is the simple y direction difference equation. You can write w2 minus w4. and then operate again difference equation on this W2 and W4. So delta x W2 delta x W4. So to write this, we write W2 again in x direction, difference equation of in x direction of W2. So that is W5 minus W6. You can see here W5 minus W6. And for W4 again we have to write difference equation in x direction. So W4 we again have to write delta x W4, that is difference equation for W4, that is W7 minus W8. So sorry, it is W8 minus W7 here. Sorry, in between there is negative sign, so the W7 minus W8 is correct. Now we go further, writing third order partial differentiation del cube W by del x cube. We can think of, again we are going to use a formula which we have derived earlier. We are going to use this in very easy way. You can simply write, locate the points. These we are going to write in x direction, so you can think of this grid in x direction and write yn plus 1, yn plus 2, yn minus 1, yn minus 2. Designate all your function values here according to the numbering given. Substitute that into this formula, and then again you have to operate on that with sorry, here there is no further procedure required, simply this equation you can write. And then for the fourth derivative, we have also seen how to write for the derivative equations. You can simply use this equation, delta x squared W. This equation we have seen earlier, so designate all the values according to this and write. Similarly you write del W by del y cube, but here you have to see now this grid pattern in y direction. Designate odd value of yn plus 1, yn plus 2, yn minus 1, yn minus 2. These values are written over here, and you can substitute that in the formula of del cube W by del y cube, del to the power 4 W by del y to the power 4. Also we can write the mixed derivatives, del cube W, del x, del y cube. So first we are going to write, simplify this, delta x delta y whole square W. So this you know, delta y whole square W. So this can be written using this formula as we have seen in earlier case. The difference equation is W2 minus 2W0 plus W4, because this should be in y direction, delta y square, and this formula. And then we operate delta x on this. So delta x W2 minus 2 delta x W0 plus delta x W4. So where is W2 is here. So when we write difference equation of this, we can write W5 minus W6. W0 we have to write difference equation, so W minus 2W1 plus 2W3, because there is minus sign, plus W4 we have to write in this direction the difference equation, central difference equation, that is W8 minus W7. Similarly mixed derivatives, del cube W by del x square del y can be written in a similar way. You just have to think about this grid, check your relevant points and substitute all the values. Also, so mixed differentiation continues like this. We are simply using the grids for writing of all formulas. del square y by w. First we will write this. This is, we are operating in y direction, so you can see here these values, and then you operate on del x square in x direction. You can part by part, you can use the formulas, substitute, simplify, you get this. Similarly, we can write the fourth order. These are the mixed derivative. Fourth order we have already derived. Now we are going to, since we are already able to write this, you can see in differential equation of plate this kind of equations appears. We are simply now going to use this equation for solving our examples. That we'll see in our next lecture series. Thank you.